Oh, so sorry. Um, I forgot that I had already hit the button. So, good morning. Good morning. Let me get some music going. There we go. I think we're just about there. Get my phone set up. It's watching Star Talk. It's a fun little show. Happy Thursday. Made it over halfway through this next week. So, got the phone set up. Good. We're going to attempt SimD today. Know how that's going to go. I've been wanting to try this for a long time, but I hadn't a project tried this on. Oh shoot, but I have a bug to fix first. I, I, oh, weird, but I heard something. From the background of this song, that's what I heard. So one of the bugs that's happening right now is that fuel shouldn't be at 300 when it's configured to be 300. So there shouldn't be a difference here. Chips shouldn't be using up their tank fuel in my sim yet. So I have something going on. I don't know where it ended up. I was gonna set up some tests. And we could kind of look through it real quick. But so far, if I cut certain things out of the sim, if I go to where hack is, yeah. It's a run battle. I want run battle. If I comment out the attacks, let's iterate faster. So I have some 200, oops, 200 million. I want to drop those. There now, it's just 200,000. Gonna be doing some debug mode stuff, so not really looking at perf at the moment. Well, let's fix that bug and then move on to the SIMD stuff because I don't want to carry that forward into the SIMD stuff. How's everyone doing on Thursday? Huh. Capitan, and to restart itself. Okay, so in this case, if we comment out attack, we do not need ship fuel. Or rather, ship fuel doesn't need to be replenished. So you can see that total fuel available is a lot. And for the ship, for the shields, and for the energy fuel, that's their weapons fuel. Oh, attempted to subtract with overflow. What function are we in? We're in refuel. Oh, get the fuel needed. Get the needed fuel for shields. Shields should be on the ship. No, something's weird. I think there's something. Hmm. It feels like something's not lining up. Like sometimes. Yeah, okay, and then 48 still on this line. Well, why didn't it do that when I had, well, more fighters? Because this one ship probably didn't get hit so much. Is it going negative? Is it trying to go negative? I'll bet this is the same bug. Because a config ship is not matching up to the Armada Defense Index. But this is it. So we're just iterating through. Technically, when we create an Armada, we should have the same number of elements in each one of these vectors. Offense, defense, fuel, kinds, and then support. What kind of ship is it? How much fuel does it have? Its shields and hull values are in the defense, and the energy values in offense. Support has some ships optionally have supply fuel, so they can supply other fuels with other ships with fuel. So I've converted it so that they're all the same size, but it seems as though they're not all lining up. I'm guessing that's coming from the spawn function. Spawn ships. Here we create an armada. I had gone to use resize. I wanted to be able to create n number of elements very quickly, but it doesn't seem as though I'm actually doing the right thing here. So offense, defense, fuel, support, and kinds are all there. Something's not quite right. I think it's because of how I'm using resize, but I'm not sure. Let's create a test for this. Create a little test for spawn. What does it want? It wants spawn ships, array of ship configs, and resources. Okay. Spawn ships. Give it configs. And resources. Okay. Now in this case we spawned nothing. It's fine. Let's create a proper config though. When we create a ship config, be one of those. Where's the other one? Where's the battle config? No. Oh, resource, here it is. Ship kind and the count. Okay. That should be up with the other thing. Same with battle config. It's basically those two things. Battle config consists of ship config and resource. Getting used to, what is this? Rust Analyzer. Trying to make it part of my workflow. Like here it's saying, oh, you're missing a bunch of stuff. It's like, yes, I am. Let's see. But how do you actually make that and those key actions part of your workflow? So filling in those structs is very helpful, saves a bunch of time. Find is going to be 0. Attack, energy, fuel, hull, supply. Actually, from my TOML file, can I just grab that? And this one has no supply fuel. Okay. Yes, we don't really need fighter config. It's just a fighter. I don't think I need all of them. Let's see, let's just go with that and maybe a cruiser. And we'll pretend that the cruiser can actually refuel things. Find is 1 there. Supply fuel, yes. It's got a tank on it. Okay, now we have our cruiser, we've got our fighter. fighter and cruiser, and then in here we need the resources. Resources basically say, of this kind, how many do we have? Kind is 0, so our fighter and then the count is going to be about just 1,000 of those, 10 of those. Test. Cruiser, we're gonna have 1 of. And then when we spawn the Armada, we expect to have 11 in each of the arrays. Say, how many values are there? There's 4 or 5? Basically, that should be the same. I'm gonna put a marker there. Offense, defense, fuel, kinds, and support. Oh wow, got too many of these. No field defense. Spawn ships needs a question mark. No, unwrap. Because it was a result, I needed to unwrap it. Okay, cargo watch -x test. Test, not text. Oh my goodness. Test. Alright, so that's cool. Actually, I want to change this now. Well, ships is going to be equal to resources. Map. Okay, that's going to be equal to total ships. So now if we toss in many more fighters, great. Now, are they in the right order though? Let's see, we have 2 cruisers. So I just want to see it first. That seems fine. One of my thoughts earlier was that somehow the spawn, the resize was actually putting the elements in the wrong spot. Maybe it's getting resized, maybe it's reallocating or doing something odd. Maybe I shouldn't be calling with capacity, because I'm not certain how capacity and resize work together. So if we allocate something that has the total capacity that we need, then I resize the array and it fills in, is it allocating even more? I don't think so. If new length is greater than length, extend width, else truncate. Using the given generator. So they just call reserve. Does truncate actually get rid of our capacity? Does it just get rid of the contents? Let's see, if I want to say there, that calls rawvec with capacity. It has a length of 0. So it has a buffer. So those two concepts, the buffer's capacity and then the length, two different things, and I'm not sure exactly how they interact when dealing with resize. So in this case, when we say extend width, oh goodness, are we allocating even more? Buffer reserve additional size. Ooh, looks like it. Looks like we are. And that's not what I intend. Okay, so I might be allocating way too much memory for this. Trying to climb back out of the tree there. Yeah. So if that's the case, then all of these should just be news. Unless there's a better way, I would rather just allocate at the beginning, say, boom, I need this much memory, and then fill it in. But as you can see, in the resize, when they extend width, they're using some, some unsafe code, so it's nice and fast. And I'm not doing that, so I'd rather rely on their code. Okay, let's go look at extend width for a moment. I think I forgot to set up the browser, so it's going to go black for a moment, and we'll fix that. There we go. So we can actually ask it what its capacity is. That's interesting. What I had been doing was using push, and I saved 2 seconds with some of these like 200 million versus 200 million ship battles by not using push. So yeah, calling resize width. That is extended by the difference. Each additional slot filled with that. Oh, yeah, resize, because it's using clone. I guess we could use resize width, give it a function, because we just have nothing in there to begin with. And we give it a function and we say resize it with this, and we keep track of how many of those elements have been produced. We just subtract. Should be, cloning is going to be faster than subtracting. So yeah, I'd basically be doing this with a list of elements. I'd be working through a list and subtracting for the different kinds and producing ships for the different kinds. Worth a try though. Each additional slot is filled with the result of calling the closure F. It's going to be a lot of function calls. Yeah, I'd rather just resize with a given value than the other way. Okay, so let's just use resize. And the other thing I could do is resize and then mutate. Just iterate through the array, setting the values inside of it. That might be the best way to go. I don't know. They're kind of iffy on this. Oh, there we go. Let's go back to the code. I know I just sent out that update, but it's not the right thing. Back to code. We'll do SIMD in a little bit. Back there. There we go. We're just going to have new vectors. Is total ships not used? Oh, that's right. It used to be used with that calculation. Okay. So whenever we go to resize it, we take the current size, we'll loop through the resources. First we'll have fighters, then we'll have cruisers, etc. We'll get the kind of the fighter, because we need to know how much energy it should have when it's created. And this is a really small array. In our case, for the test, it has 2 elements in it. We're going to resize it from 0, N, for our fighter fleet. Should be fine. Just look at this. Ship defense. Oh, I read that as null. Ship.null. The whole. Armada defense length. Let's resource count. Yeah, all that looks fine. What's this one? Oh, this one's building up the kind. Okay. So we have to expand out how many different kinds there are into the arrays so that we can map them for the SIMD stuff. Okay. What else should we test here? We should test that all the contents of the arrays probably. We have 10 cruisers and 2 fighters. I'm going to assert that. Let's see, is there a vector or iterator function to check that everything is the same? Oh, all? Ah, good. We'll use all on that then. Because they should all be pretty much the same. This all's not correct, is it? It's going to be either for like the shields. The fighters have different shields than the cruisers. We should have 10 shields and 10 shields at value of 10 and 2 shields at value of 10,000. I need some way to express that. I guess I could just stamp that out. Insert equal. What do we have? We usually do actual than expected or expected than actual. Yeah. Looks like we're doing actual up above. That should compile, that should fail. Good. Now in this case, I want 10, insert 10, comma, escape. 2, insert, escape. Can't compare. Oh, because the integer types are different. Okay, I need to decorate the first one in this list with the type. Underscore ship resource. It's a U16. It's supposed to be a 6. There we go. Map that. Oh. Energy. And it's not going to know what type to collect to. Hold on. Oh, energy. I was to defense. So I was doing defense. My shield is only 1,000, not 10,000. All right, just stamp a couple of these out. Let's do offense. Okay. And what is our offense? Our offense is going to be energy 3,050. Good. What's next? Fuel. Let's keep them in the same order. We have offense, then defense, fuel support, fuel kind support. And what did fuel have? Fuel had 105,000. Insert 10. I don't know. Is it 5,000? Fuel. Kinds and then support. Oh, that's right. We don't have a value in there. So the kinds in this case, 10A, it's going to be zeros, followed by a 2, a 2. Oh. 1 and 1, of course, because I was based on the other config, which is still stuck. It's like burned it in my head. And support. Support is going to be none. It's going to be 10 nuns followed by 2 things, 2 sums with 30,000. Supply fuel. Oh, that's right. Wait, why would I even map that? 10 add none, comma. We still have to do this. Oh, iter.map support. Now this one is an option, and options also have maps. So s.map. Need more space there. Oh, come on. Now for this one, s.supply fuel. We collect it. We want a vector of optional optional U8s, U16s. All right, all that tests out. I wonder if the bug's still there. It is. Why? Why is that there? Oh my goodness. Okay, so it's not in the spawn code. Not in destroy. That happens too late. It doesn't happen too late. I forgot to remove some. I forgot to remove kind. Oh, that's it. We're out of sync. Yeah. All right, on to the SIMD stuff. It was a kind bug. Very nice bug. All right, part of the reason that I set up the resources this way was so that we could actually use SIMD more easily on it, or at least I believe make it easy to use SIMD on this. Because I've never used SIMD before, but I think it would be fun. So we're gonna go down that road. So we're gonna need to do that. Well, I said need. I don't really think we need to, but it'd be fun. So the way that attack works, each ship is getting a chance to shoot at something else at random. So the first thing that we do is we go through the ships. And so they get to choose a random target, right? Basically a random opponent on the other end. So we're going to end up with ships attacking an index. Now that random index matches up to basically the battle line on the other side. Right? If you're, space fighter, 10 in that line, a gigantic line, then that attack is for you if this is 10. Now, if multiple ships attack and roll the same thing, you might have like, oh, well, this guy attacked guy number 1. This was guy number 2 in his spaceship. These two at the ends, they both got guy number 10. So we need to create another array. Okay. So for every ship in the battle, we're going to calculate how much damage they will do to somebody on the opposing side. So I think the first thing is to basically have a gigantic array. In some cases, it'll be like, a billion ships. So we're going to go billion versus a billion. I think I want to pre-compute how much damage is going to be done to the opposing ship by just putting it into an array. So let's see, I did get that committed, right? Get status. Okay, good, because this is going to get messy. It's basically for every element in the offense, we are going to consume their power adding to this array. So maybe we should have some gigantic array first. Let shot energy. It's going to be a vector with capacity of however many there are in the defense line. So if you have like 1 million attackers and like 2 defenders, it's going to be that little red hot puddle of metal in space. Target dot length. Oh yes, and I want this to be let's see, this needs to be I was gonna say it's like a U-16 or something. Because is there I don't know if I have any ship that has shields plus hull that's gonna be greater than say 65k, 64k. 65,535. I think we could say this is a vector of U-16s and take up a lot less space and memory. I don't know how the SIMD stuff is going to work with that. We'll see. It might need to be some larger value. I'm going to basically break this apart into how I think it should be done in SIMD, and then we'll go back and do the SIMD equivalent of it. Also, I'm not sure that I can get the random stuff in SIMD the same way. That's kind of why I want to break it into 2 pieces here. Okay, so that's not a big piece of code. So the shooter is here. Yeah, and he loses energy for the attack. limited by how much energy it has. Technically, at that point, the target stuff should be down below. I think it's going to be just this stuff here. We look up at ship kind. With the amount of energy. I mean, maybe we should do that in like 2 phases. Have an array that just is that ship's energy. We could store it with the ship if it'll make it faster, but trying to play this balance between memory and CPU. Where's the target? That's here. Sorry. And then the shot energy is going to go into index target. I'm gonna do a saturating add on that. Hey, good morning, Carter. How's it going? Unused must use. Really? Why don't I get documentation on that? Oh, we had pho last night, Carter. We made pho at home. It was very tasty. It was nice. I really liked it. And we didn't have like I would have liked to have some jalapeno in it or something. But I had sriracha. It was good. We also had some yeah, a bunch of some other Asian spices. Um, it was really good. I'm trying to remember the names, but I can't pronounce the names. Okay, the saturating add. Use return value must be used. I thought that saturating add. Let's say it's for U16. I doubt it's different for each one. Oh, it doesn't auto. That's right. It doesn't increment. Let's say that is equal to that. Shot energy is equal to the saturating add on the shot energy. Oh. So this should collect all the shot energy that should be applied to the target ships. Then we go through all the shot energy, applying it to the target ships. It's down here. Or, oh, my Vim fingers are not on today. I think just my fingers in general aren't on today. Target ship index in 0 dot dot. Shot energy. Oh, we have a cycle? That sounds cool. I've never seen this error. Am I actually calling attack in here somewhere? I'm only calling attack in 3 places. All right. Oh, when checking the type body, the item types. Oh, okay. Trying to figure out which one. Guessing it's in here. Just comment it out to see. Oh, shot energy dot length. That's not used, and I would like to rebind this. I do not want immutable past that point. Okay, so something in here. Oh, the attack. That's what it is. Attack here is going to be the function. There we go. Well, this is interesting in that, well, we've split the attack into kind of collect all of the energy that's going to be applied onto a ship, and then apply all the energy onto the ship. Work? It does. Wonder if that has any performance changes. Oh, and I was able to get Xcode, what is it, the instruments tool running on the binary. Okay, out of bounds. The length is 0, but the index is 392,000. Now with more backtrace. Is it trivial to set up Xcode with Rust? I think one of the important things that I needed that we got from the flame graph stuff that we were talking about yesterday, this debug equals true in the profile release stuff. And it was incredibly easy. If I could, I don't know how this is going to show. Let me see if I can resize this window. Give me a moment. Okay. I'll get OBS set up. Just a moment. It's going to be black for a moment. I want this one. There we go. So here, if you start up instruments, it's pretty simple. You can have environment variables and arguments and the working directory, which I need for the config files. I should put the arguments in there and undo the stuff that I had in main for FlameGraph, but I'm leaving that in there because I'm still playing with FlameGraph. And then you just select the binary, you choose that, and then you can run it. If we hit run here, it's going to go through. We'll run it, and then it shows you like the heaviest stack trace on the right. Unfortunately, we're hitting that error at the moment. If I go back one, see that in the attack section. I know the font is tiny on this. I apologize. But you can see that, hey, this is the heaviest piece here. It shows you how much time compared to other things. And I had to do nothing to get this to work. Just configure it. Having debug equals true in there does help with the symbols that it shows you. That's really nice. We might bounce back and forth between that. Let's fix this panic. Just want to run it. Okay, where? Begin unwind, battle test sim attack 295. Oh, it's saying that the index is out of bounds for shot energy. Oh, of course it is, because we didn't create it with values in it. I want to start with zeros. There we go. That's better. Okay, now it's full. So if we go back to the 200 million on 200 million, sense of, oh, the spawn changes, they are taking a lot longer. I think having it pre-allocated actually helped before. Yeah, because 17 seconds pre-allocating that is not a good change. Here, instead of that, we had width capacity on these. Total ships is going to be equal to the resources map. Yeah, because I have a count and a kind in there, and we just want the count. Sum that up. Okay, now here, with capacity, also this is debug mode. Wow, it's debug mode that much slower. One of the other things that's very, very useful is in your config stuff is to set things like optimization level for your build tools. You don't need some of your build tools to be like insanely spec'd. You set its optimization level to 0 or to 2, etc. Goodness. Is that the difference between release versus not? Wow. Just wow. That is a substantial change. Wow, 17 seconds? Oh, that also includes the compile time. Run it one more time without the compile time included. I kind of want to try it both ways. One with little ships and with capacity and one without. I want to see if that has an effect on the spawn duration, taking like 3 seconds. So 24 seconds for 200 million versus 200 million space battle. That's not bad. Actually gonna just copy and paste this here. All right, and if we do this, let's build it in release mode. We'll see if it takes 3 seconds. What was that number up above? It was 2.91, 3.67. Those are it'd have to be quite a bit different. It's just in line. It's fine. I'd rather have less code. That's not bad at all. Okay. I'm gonna add that. See, split attack into collect energy and apply. Okay. Next, I'm gonna optimize this. I think this one's going to be the easier one to do because it doesn't have the random stuff in it. We tried this one first. Curious about the random bit. Like, can I just from this attack distribution, can I get like n number of random values into an array? That'd make this even faster. Because if I could apply this multiple times, then that also gives me the multiple shots that I want. Because technically, I'm not doing this to the specification yet. When a fighter fires during the round, its attack applies damage of 10. However, it has energy in its weapon system, like in this case 50 energy, so it can fire 5 times. It will empty in its energy in its combat system during the round. So I need to apply this multiple times until basically all the ships are out of energy. I think probably up to some maximum. Either that or I loop in there. Yeah, lots to think about for that one. But for this half, we're just applying the energy onto these defended armored targets with shields. It's going to say poor defenseless targets, but they're not. Let's see if we can get this done in SIMD. So let's go up here, SIMDs, what we're going to be using. Also open this excellent Intel intrinsic guide. It's got some comparisons and whatnot. Here we can toss that over there in case you're interested. Yes, basically what you do is you create a function inside of this SIMD runtime generate function. Inside of there, you can use these sort of magical S : components to be able to interact with SIMD intrinsics. I think I said that correctly. I don't. If I didn't, let me know, please. So here, load, and down here, store with subtraction, etc. Result set length, x.length. Oh, interesting. So in this case, it's creating a vector result. Oh, that's this here. I wonder if I can just have it store into a given array already. Or if I'll have to go through and apply that after the fact. Because I'm going to need 2 pieces of output. I'm going to need shields and hull. I could do this in 2 stages. One that takes some value from that. Let's look at this. What is the load UPS? This is the intrinsic guide that they have, and you can have this little search here. Looks like they're using this load UPS. This is a really neat thing. I looked at this last night. But 128 bits. Those are 4 act single precision 32-bit floating point elements. Does not need to be aligned on any particular boundary. That's neat. Latency is 0 on Skylake. Wow. It's neat that they have these numbers down here as well for performance. All right, and what was the other one? The other one was store. So here's store UPS. It's interesting, all these other variants. Store it somewhere. Okay. We'll have to see if we can just store it into one of the arrays that's passed in. Because if we can get the energy, save some of it to the hull and some of it to the shields, that's really good. Now, according to their documentation, which I'm not going to take you to because I know I've left people in the documentation before. I apologize. I'm going to toss some of the SIMD stuff in the top of this file. Oh, did I not add that? Cargo add SIMDs. Cargo. Okay, and we don't need the algebraic stuff from Sleef. Let's get that checked. Okay. Okay. And then we create a function. Now I need to extract. Oh, I got lost in here. Where's attack? The function. I went to the field before. So this here needs to be extracted into a function. Okay. Nomad, morning. How are you, man? Let's see, what is this? Apply attack. Need to pass in the target ships. Actually, in here we just need to know, sorry, for the first half of this, we don't even need the targets, just how many there are. Second half, yeah, I would think I would prefer to have this return this shot energy vector. First half. So we'll say like build attack and apply attack. All this will be target count. Just pass in a number. And this is going to return a vector of U16s. No longer need total ships. actually. CGN, target count. Next. I'm doing well. Let's see, I'm looking forward to trying out SIMD stuff. I haven't done it in the past. So we're gonna see how much perf we can squeeze out of this acorn here. So in this case, we'll return an okay. We're building up the attack. So before each ship applied the attack pretty much right away. But now we're collecting all the attacks that I've never used SIMD. I've seen it used, but that's about it. So we're collecting all the energy that's going to be applied to the defense. And late last night I went through and restructured this so that I think it's more SIMD friendly. This is function apply attack, and this is going to take, see that vector. It's going to just be shot energy. Or attack energy? We'll call it shot energy and rename it. This is going to be a mutably borrowed vector of U16s. And then the target or armada. You used in C++? Before helps quite a bit. Oh, nice. Oh, you were a perfect use case for it though. That's cool. Yeah, I've seen it used in vision stuff, computer vision. Gonna be immutable armada. I don't know what we're returning yet. Just gonna give it something. There we go. Formatter kicked in. Now the shot energy. Rename that to attack energy. There we go. Yeah, I worked at a place that did computer vision with sports stuff. It's pretty cool. All right. Now here we're going to have gigantic arrays. And so in this case, attack energy is going to have, in my current test, 200 million U16s. And the targets will also have some basically 200 million elements as well. Maybe mainly on the comprehension side. Oh, neat. It's cool. Like having computers understand what things are via computer vision. It was really hard hiring for computer vision, actually. Because when we'd get people in, it would either be theoretical computer vision people and couldn't code at all, or they were the opposite. They had seen it and been exposed to a lot of it and studied a lot in college, but and were good coders, but not really good at computer vision stuff. And to be honest, I'm not on the side of like being able to do computer vision stuff. That's not me. I was like a different part of I was part of the cultural fit in those interviews. So I worked with really good computer vision people, and this is what their feedback was. Oh, fingerprint David. Yeah, yeah. Gotcha. So yeah, it was really hard to interview for it. That's funny. I think we did get somebody out of out of that was tired of doing government work, and he came to do sports work. But he was good at he was good at computer vision. I need some water. Hold on a sec. All right, finish my water. I'm gonna pour some tea. That was a fun gig. It's really intense though. The sports stuff, you just like your deadlines don't move. Oh, brand recognition. That's cool. Brand detection of sports games. Oh, nice. So you can actually see like, oh, is how well is Pepsi represented at this venue, and that's cool. Of course. The sideboard at ads at games and stuff. That's neat. There's some of those ads though, like you'll see they're just green screens, or during broadcasts they actually get replaced. Right, so there's a build attack. We're gonna apply that attack, and that wants the energy. Could just give it the attack energy. Yeah, we'll change that signature. I don't want to keep it around. Help the compiler. Oh, and the targets. So who's going to be applied? In this case, it's going to be the defense, and we'll do that. Defense, attack energy. I know. Signature's wrong. Okay, we're going to own that. We'll do the same thing here. Apply attack energy. And this time the offense is on the receiving end. Oh dear. My wife has sent me a picture. I made a mess in the kitchen. Oh, I feel so bad. I didn't know. I basically set up the water filter again to go, and but I forgot to swap out like the reserve, like the thing that it collects into. And so it's overflowed and it's all over the kitchen. I feel so bad. Oh, my goodness. Okay. Fly attack. I think this is building good. Yeah, a bunch of SIMD stuff not actually used. And just to check, let's give this a build. Give it a run. And there we go. Let's give it a run. Where is it? There we go. I wonder how much overhead there is in the backtrace piece. Oh, I also want to see how much memory it's using. Probably add that profiler, can't I? Allocations. All right, 34 seconds. Let's run that inside of instruments. No, wrong one. This one. I think this is it. Run that there. Added allocations here. 5 gigs of RAM. Because that's all you need. It's five gigs. Plus smidge. So it went down and it came back up. All right. Well, actually, while you're here, we can actually look at this a little bit closer. Dig in. Of course, we split this out into two functions now, so we'll be able to see which of these functions is actually taking the lion's share of the time. Here's attack. And what does it say saturating add is taking forever? Seem right. This is build. Build attack is taking a long time. Apply attack took 1 second. Oh my goodness. 1 second. But why is it saying that saturating add is taking that much time? Is it just because that's where it's sampled? I don't know how accurate these tests are. I mean, we could do something else instead of a saturating add. This is instruments. It's part of the Xcode suite on OS 10. So this is the core that we were on at the bottom. But I'm guessing that this 13 seconds, is really just saying that somewhere in there, this actually took time, and saturating add is the only function that it really landed in during its sampling. So it thinks that saturating add took that much time, but I don't think saturating add takes that much time. I thought saturating add was just a couple of instructions. Oh, where is it? I really don't think we're going to get a performance gain by swapping out saturating add. I don't know assembly well enough to be able to parse this. Move Q. Hmm. Let's see, where is that saturating add? Ah, that's right. The build attack. This one. I thought saturating add in Rust was implemented. If we go to the browser, come back over here, saturating add, we can look at the source here. Intrinsics, saturating add. Yeah, And on the target platform, it should be just fine. I think the instrumentation is just landing in the wrong spot. This is one of those points where I don't trust the profiler. Because it's a sampling profiler, right? The instruments. I think what I should take away is that build attack actually needs more help than apply attack. Apply attack finished in 1.3 seconds. All right, let's subdivide build attack one more time. Oh, back to the code. So build attack is two things, right? It's choose and then attack. I'm guessing that this sort of attack distribution piece here is actually the most costly, this entire piece. Sampling 200 million or 400 million random numbers is expensive. It's a few instructions versus a regular add. I see, but it's not, I mean, and it's nothing compared to like sampling a random, I mean, the sample is O of 1, but still O of 1 of something that's really slow is still slow. I think it's happening here. I want to pull this out into your element. All right, I'm going to generate the targets outside of this and pass in a list of targets. Now in Rust, the array indexing is always usize, isn't it? What type is attack at array? Oh, here? It's a U16. Attack is a small amount of fairly small. I could have indexes. Let's see, what is... Let's say that there's like a 32-bit limit on the number of ships you can have in an armada. So that'd be like 4.2 billion. Okay. Basically, take this out of here, put all of these random samplings into this vector, pass that in, then this function doesn't really have side effects the same way anymore. It's a little bit more predictable, easier to test. Oh, interesting. x86 might have a single instruction for that then. Oh, because it's usize and it's taking up just a portion of an instruction. Is there what, 512 wide now in some cases? 128 at least. I guess it depends on the generation of the CPU, but okay, let's build up a random. Oh, for that saturating ad. Yes, yes, yes. Build random targets. We'll do this over here. We're going to pass in the target count. Sure, that can be usized, and then we will return a vector of U32s. Take that out of there, that out of there. This. It's over here. Okay. We'll return targets there. Isn't targets? All right. Now, what is the quickest way to generate 200 million random numbers within a target set? Because here we have a distribution. It's a uniform distribution from 0 up to, but not including the target count. And I want 200 million of those. See, if this is a vector, we can say, just say it's a vector, new. And then we can say we want to expand it with a function, as we were looking at this earlier. I think there's an expand with. Oh, resize with a new length and provide everything with a function. Okay. So we have our vector. Resize with. The new length is going to be the, oh, come on, window, you're covering my value. It's target count, and we give it a function, some closure, and do this. It's going to be a lifetime issue, isn't it? Because of the mutable RNG. Oh, no, it's not. Interesting. Sample always returns U size. So our target count here is U size. We say that's a U32. Do we still need that? No, that's better. Okay, because it's returning something that's within the size of the type that we give it. Okay, that's better then. Build random targets. We'll pass in the random targets. and then use the random targets. Let random or target ship index is equal to random targets and our ship index. So given this ship index, what is our random target? The type U16 cannot be indexed by U32. Okay. Now let's go build some random targets just before we build the attack. Same thing for offense. Okay, and then just that stuff at the top. It's cargo. There's my release build. There it is. Yeah, CMD stuff. We'll get there. Do you have timings for that? I think we're gonna run it in instruments after this. Then we'll be able to see the difference between where the time is. Is it inside of the attack, build attack, or has it moved over into build targets? So yeah, that looks pretty consistent. Let's go back over here, give it a run. Oh, the allocations. 6 gigs. Only 6 gigs. They do have some compressed vectors, don't they? Because if it's the same number over and over again, they can compress that. I think some of my values don't change. I could reduce memory because of that. Okay, let's say start. Here's a battle. Drag this up. Gain Rust. I think there's some libraries that give you kind of the vector interface, but they do like run length encoding behind the scenes or something. Okay, what took the most time? Build attack, still. Saturating ad. And where? Wait, turn that down. I don't see. Is refuel, spawn, destroy. I don't think this picked up the latest build. Apply attack, resize with. Here, let's try this again. Edit. Want that. Run it. Because that other function should have taken a lot more time. The one with the random stuff in it. Build attack is still taking a lot of time. Does it even say that the random stuff is in there? Oh, you haven't seen any. I thought I saw one the other day. You know what's interesting? Build attack doesn't have any of the random stuff in it anymore. See, if we go back, yeah, because here build attack has random number generator stuff in it. Oh, it could be inlined. It is a release build. Yes, it is. That would mean that the parent function, which is not build attack, would then take on that time, right? So here we had 22 seconds, 22 seconds. And then here, yeah. So it does look like the parent function did take that on. If we look at this, build attack is down to, okay, 13 seconds versus 15. See, if we click there, okay, yeah, we got this source. Oh, this is main. I want main. Go back. I want build attack. Interesting that main. Yeah, it does look like stuff got inlined up. What's interesting? Interesting to see that build attack, so it didn't go down that much by taking the random stuff out. That's surprising. I am actually very surprised about that. I thought the random stuff was going to take a lot more time. I'm also surprised that saturating add is still the big target here. I wonder why. Is it because I'm operating on an array? Yeah, see, 26 seconds, that's pretty good. That's a good run there. I mean, maybe we undo the saturating add. Let's do it some other way. So all we're trying to do is basically increase up to this thing's maximum. Let's see, what's its current energy? Current energy is going to be equal to a shot. It's going to be equal to that. And we could pull this into something larger. So it's like, oh, it's a U32 now. plus attack. I know attack is also tiny value. And now we put back in there whatever's less, the max for U16s or well, the new value. U16 : is it dot max? Oh, I didn't leave you guys over there, did I? Oh, I'm so sorry. I did. I'm so sorry. Shouldn't have to stare at instruments for so long. So what I did was commented out these two lines. This is the original code here. And then figuring out just a different way to do this. I want to see if that moves and if it has any effect to do this in a slightly different way. So here I'm just taking these values as U32s, adding them together into current energy, which as a U32, of course, it can hold a value larger than a U16. And then we'll compare and see, well, what's larger, a U16 max or current energy dot, is it dot max like that? Okay, because we want to take the minimum of either max, we'll call min on that, or current energy. Expected value, colon. Right, I'm gonna risk the browser, use 16. Constants max, or U16 max, standard U16 max. And it's gonna say, hey, this isn't a U16. We have to do this the other way. Current energy to min. Oh, that should be standard still. That should be it. Build release again. There we go. $16 seconds for the attack. 28 overall. Well, we could try instruments just for giggles. Just to make sure we choose the right thing. Yeah, I just don't believe that the saturating add is going to be slow. And of course, it's not going to be in there, so it's going to say, oh, you know what? Now it's going to be minimum, or because we have a min in there. Why isn't it choosing the other max? Is it just because of where the sampler hits? The cadence is just precise. It's always hitting on that one thing. Let's see. Build attack. Oh, still 12 seconds. Yeah. Look now. Oh. Moves UWL1. Is this because it's just random access? Like it's really slow writing to random memory? Well, but that's just the performance of writing to random memory like that. The other elements are just sequential, and this is a random write, which is like the worst of all cases. Random read followed by random write. Is there a way for us to flip that? Because yeah, it's going to have to fetch all sorts of, like it's going to be paging all the time for that. Well, depending on the size of the value. I'm sure this doesn't all fit in one page. What would the page size be on something like this? On this machine, this has 64-bit OS 10 box. Trying to come up with another algorithm that doesn't involve random access like that. Like, can you go from start to end on both of these? No. Maybe. Oh, maybe. Maybe we say who shoots this target. But then we wouldn't get multiple targets being shot multiple times. The nice thing about the way it currently is that all of the shooters in this case, all of the ships could shoot the same single target. Split them out and sort them. That's interesting. If I sort the choices though, then they lose their position. The attacker changes. Yeah, I think if we rearrange rearrange them. I guess that's the other thing. We could just randomize the targets. I mean, let's think through that. What if we just randomize the targets? Because the targets is just some giant vector, right? Because we still want to be able to. Is that target here? What I find interesting, so let's go back up here, where we're sampling. This is fine, right? We're just going front to end, generating 200 million random numbers. Fine. Up here, oh, where to go? Up. I lost the function. Build random targets. No, that's the same one. Oh, okay. What was I remembering? I was remembering something else. Wow, that train just crashed. That train of thought just gone. I was surprised. I thought I had one more function in there that I had. All right. I need to also subtract the energy from the attacker. So we have to have that. It's going to be random either way, either at the front end or the back end of this. I'm going to put the saturating add back in. I don't think that this helped. All right, well, this might be something that we could do SIMD on, though. Could we do this? Apply to, what is our output here? We are adjusting the attacker's energy. I need to change that. The vector to not be, this ship offense is really just one thing in here. It's got a U16 in it. I also wonder about this. Because really I want to know what the energy is. What the max energy is. So the attack minus the energy. We could pair those up. So that we're not doing this extra lookup here. If we're just going to throw memory at the problem. Hmm. I'm trying to weigh that idea. Not a fan of throwing more RAM at this. I'd rather have some other way to make getting this back power more easily. Like if this was built in, if I could say, like if we had hard-coded ship lines, that could be constant. Hmm. So I have to do two lookups. I have to get my kind of the ship. Yeah, we're doing two lookups there. Let's just pair it. Okay, where is that? At the very top. Offense, we're going to toss attack. This is also going to be a ship resource. Okay. Give me the errors. I think it's called that. It does get removed. Yes. Part of the battle here is after the attack. So we have the attack up here. Then we destroy the ships. And that's actually removing elements out of the array. And part of that is the swap remove. So we're taking the tail of the array and pushing it up into the dead ship slot. So yeah, we should be able to reduce the amount of memory that we need. At the end of the turn, it does, yes. Because during the battle, everybody shoots at the same exact time. And so imagine it that way, where there's just like a blast of energy and everybody got hit and everybody shot everybody else. And then after that moment, we, cull the ones that were disintegrated and whatnot. So the attack, I think, is near instantaneous, like boom. All right, we were in build attack. So here, I'm gonna get rid of the shooter ship, which means I can get rid of the kind. Do I need the ship index still? Oh yes, I need that for the random target. Also, this enumerate, I'm not sure if I want to do this way or the other. The other ones aren't using. I might move away from that pattern of iteration. So in this case, the attack is really just going to be the shooter dot attack because how's that? Don't need that anymore. Remove that. Yeah, we're going to do this in two stages. I want to go through and test, see if that had a performance impact, and then I want to change the way that we're enumerating here. I know it's funny. Could probably use that random list. You could use that for both the offense and the defense. Just produce n number of random values equal to the maximum number of ships, and then we don't have to calculate it twice. I don't know how much time that'll save, but it will be less. Yeah, I really think we should do that. So there we're at 16. So actually that saved a little bit. Now we're at 22. Oh, it panicked. It's destroying ships. Oh, we hit the end. Is that reproducible? I did not think that changing this would cause that. So probably something strange and random going on. That's unfortunate. So we ended up hitting the end there. I didn't have a backtrace. Okay, we'll leave the backtrace stuff on and hope we hit that again. Out of bounds. Here, let's look at destroy for a moment. Oh, I have to actually do this before, because the Armada kind, the last one in the list had died, and this Armada.kinds had been removed before we got to it. That's probably what it was. To record the loss before actually removing them. Okay. Oh, what was our duration? Real was 32 seconds. Okay. Offense length is going to be equal to shooters dot offense dot length or do that. Oh, that's ship index, isn't it? Ship index. I have to get the shooter, let shooter equal Yeah, we'll run that. I want to. Wonder how the SIMD stuff is actually going to work with values being kind of stuffed away like this. So I have values, energy and attack are on the same object. Do I need to extract those ahead of time? Or simply just provide those as inputs to this? Yeah, I'm not sure. Actually, 25 seconds? Kidding. Can't be. Gotta be like 14. 14's not bad there. But yeah. Hey, maybe that helped. Alright. One thing that I would like to check of time here. This build random targets. These random targets, if we took the largest of the offense and defense and just created n number of random targets for that and use them for both the offense and the defense, it should provide random enough information for attacking both sides, but not have us build that list twice. Let's do that. We'll build the random targets. Oh, where's offense length? Too far down. There we go. Also list that out. Now let's make sure that we don't iterate through the random targets. I might have presumed that they were going to be the same length. Oh no, wrong one, not there, here. Yeah, this is incorrect. This should be, return value here should be the same as the shooter's length. Oh. There we go. Otherwise that looks good. Okay. Kind of wish I had separated that out before so we could have seen the time difference. I do think that was getting inlined, as you said earlier. Okay. Oh, it took a second. So we saved a second. Yay. Actually, the attack duration was down too. All right, let's see if we can make this a SIMD thing. Actually, let's commit it first. Source. Okay, let's make a SIMD one of these. I think the signature is going to be slightly different, as the SIMD stuff isn't going to want an armada. Just guessing. I don't think it's going to want the armada. What is it going to want? Just the shooters in the armada, most likely. Now let's see, I'm looking for that documentation. So we need to define a function. We do that in one of these. So the documentation's actually over here. Come back here, SMD runtime generate. I actually have to give it a function. We will call this build attack. I'm going to take something and return something. Function build attack. Okay. Actually, what is our cargo watch? Good. Oh, interesting. Yes, did we ever return an error from this? I don't think there ever was an error inside of this build attack. I'm going to strip that result out as well. Okay. So we're going to take a bunch of stuff. We're still going to return a vector of U16s. Okay, we'll get to that in just a minute. One more. Okay, now to build this for the SIMD stuff, still need the length. So we need three pieces of input. We need the random information, random targets. I'm going to keep these similar in their function signature. then I think this armada here is going to be different in that how do we map this to this? I'm looking at their documentation thinking, can I even pass in this type? I don't think I can. So I'm just a novice at like all this SIMD stuff. So I'm guessing that I have to pass in something else, something that actually has here types similar to this, where you can then operate on things like load PSU and give it an address that you want to pull from, right? So give me this, and do things. This is kind of the meat of it, where things go quickly, right? This is just set up here, then here they start to parallelize things, or use SIMD, right? Single instruction, multiple dispatch. Is it dispatch or destination? I think it's dispatch, isn't it? Yeah, this here, XV1, XV2, all this stuff. I'm going to see if I can split this out into 2 elements. Because we want hack and energy. I don't even think they want slices. Can you? I wonder what the SIMD runtime generate can actually take. Wish they had examples. Oh, they probably have examples. Well, they have tests. Distance test, okay. Hmm. Shows you how to call it. That's nice. It's quick check. Hmm. What do a paste is? I saw that as one of the other crates. Test 1. I have a vector of numbers. All right, go back. Back to the code. I do think I need to set this up differently. Well, this is probably going to have to be mutable, isn't it? We'll see if I can even do that. I don't know if somebody's going to be allowed to do that. We'll see. So for this attack, it's a ship resource, which is technically U16, but as they attack, their available energy goes down, and then the output of this is going to be how much damage is done, given the random targets. No rules expected. Do they not want the... Strange. Is this going to be because of the formatter? Oh my goodness. It's because of the comma at the end of that line. Wow. Oops. No, I killed it. Okay. Attack. Build attack. Here we go. Wow, their little macro doesn't like the trailing comma up there. That caused a whole bunch of lines to unfold. Okay. Technically, this is the attack, not length. Just create an array with all zeros. And then we return shot energy. Technically, you should be able to build something with this. Everybody shoots the first ship, a ship with index 0. Okay. Now here, this offense and defense bit, bold attack. Interesting. Let's spawn our ship slightly different. We're going to split offense into attack and energy. Yeah, I know. Not going to be a ship offense anymore. I had the types there because I wanted to make sure I wasn't clobbering things, using the wrong array. I wanted the compiler's help with that. Okay, there's that. Let's go. Oh yeah, that's broken. That's fine. So in this case, we're building up the offense. Say this one's going to be for attack, and this one for energy. It also might help testing how the storage arrangements affect perf without SIMD. Yes, agreed. I think these are going to be fairly consistent in that I think those types actually get compiled away, right? Because they just have one element in them. They probably just vanish, right? So I'm going to just duplicate this one again. But yeah, how does it fetch them? How does it... Because before they were right next to each other, they were bundled. Yeah, there we go. Oh, and I want to attack. See, now this is actually okay. This wouldn't have been okay before. So I have to be even more careful not to clobber those. I do like having those extra types. Oh, I know. I can use a type alias. Type attack is equal to a U16, U46. Wow. I think this works. I haven't done this before. All right, now we have ship attack, ship energy. Now, if I was to screw up and say, oh, you know what, this thing goes over there and that. Oh, because ship energy isn't of that type. Let's see, where's ship? That's going to be from the ship config. The attack is going to be ship attack. Trying to find that again. Oh, come on. No, that doesn't help at all. That's too bad. I was hoping a type alias would I know they're both like U16s behind the scenes, but I was hoping the type alias would keep me from tossing one where the other belonged and vice versa. See, did I do that correctly though? Attack, energy. Yep, attack and energy. All right, just got to be a little bit more cautious now. So yeah, as you said before, I should test this without SIMD, so I'm going to do that first. Attack is going to be ship attack. Energy is ship energy. The attack is not mutable, so maybe we should use that one. I hope Rust sees this and says, you know what, that's not mutable, so I'm just going to use a constant value there. In this case, we don't need shooter. Hmm. In that case, I can probably do this. There. Now, shot energy, get the target ship index. Wait, come on, it's a U-16. I shouldn't need to do that. So we have two of these now. We have attack.length and energy.length. Oh, that's right. I didn't have the test for the other one before. Yeah, I don't know what the attack is for this. So it's 10 and 150. Okay, so instead of passing in offense, we'll pass in offense dot, what does it want? It wants attack and then energies. And that's not mutable. Energies is. Oh, same thing here. defense.attack, defense.energy. Ah, for refueling, yes, yes, yes. What are we looking for here? Is it just an index? Might have been. All right, armada.energy index. And we do not refuel attacks, so that's fine. We don't have to modify anything else there for the attack. Are we still in refuel? Yes, we are. Getting those up. Was now ship energy, isn't it? This has to be immutable reference to that, though. So it's pointed to that. That. Energy and attack. Good. Those are gone. Just wanted to check to see if I had any other strange references to this energy object. They look correct. Okay. Now we're gonna run the build. Not the build. We're gonna run the test. Fourteen seconds. $33. So that, I think, had a negative effect. Let's run it one more time just to see. Maybe it had to fight for memory or something. $12. Okay, that's better. Yeah, okay, that's more in line with what we're expecting. So no overall net negative then. Add source, Rust format to TOML, Argo, sure. Let's see, we split offense into attack and energy. There we go. Now, build attack. Now that's the same sort of format that we have for the SIMD stuff. We're going to swap to now. Okay. I want to see it just build and run. I know this is not correct. Like that code is broken there. But this is what I'm looking for. I'm looking for these errors. 5 penetrations needed. Ah, yes, yes, yes. So when we call this now, oh, where is it? Our documentation? Come on, SIMDs. Where are you? Here we go. Example. So yes, this function here, the SIMD runtime generate, creates a number of functions depending on which you have. This will generate 5 functions for you. We probably want to do runtime select to let it just pick the fastest one. Yeah, I think they even mentioned that down here. You can use any of these. You would use runtime select version unless you want to force an older instruction set to avoid throttling or other arcane reasons. So we're going to use the runtime select version of that. Let's go back to code with runtime select. Okay, yeah, we know it doesn't need to be mutable yet. That's fine. Just wanted a starting place so that when we're building on top of this, it's okay. Good. Now this should be much, much faster because it's doing nothing yet. Well, it's doing nothing. Not doing anything. Attacks very quick. Great. Kind of our baseline then, isn't it? 14 seconds. There it is. Set a marker there. All right. Now, how do we do this? We have a result set. Now, here they say the operations have to be done in terms of the vector width so that it will work with any size vector. Okay, cool. The width of the vector type is provided as a constant. The compiler is free to optimize it more. Interesting. So there's a VF32 width. Where does that come from in here? I wonder what the other options are. Is it a vector float 32 VI? There are a number of things in here. Ooh, 16 width, 32, 64. Oh, we're working on 16s, aren't we? So we could use a VI16 instead. Looks like they only have 32. Okay. Gonna do one of these. Come on, fingers. We want the VI. That was VI 6. Stop. I got the windows selected over there. Hold on. VI 16 underscore width. Got it. All right, now what are we doing up here? We have the attack, we have the energy. So we need the attack and the energy, and we choose the max of those. And then reduce the energies. Okay, so we're reducing the energies by... Now we need to load this, s : load. Oh, if we want to load a 16-bit integer from this, it's going to be load something. Then we're going to have to give it the attack with I in it. It's the index. I prefer index. It's going to be something like that. We need to figure out what the load instruction is for the 16-bit integers. We'll have energy, along with the same thing from energies. Okay, so let's figure out what it is there that we need. Let's go to the Intel intrinsic guide. Let's do this. Load. Load USI16. Do I have dot files? I do have dot files. Hey, Super Fortnite guy, thank you for the cheer. You're welcome. And Clever Code, if you have questions on those things, just let me know. Okay, so we need to do the load USI16 on that. Oh, do I have caps on or something? No. No, really? I would have expected that to be there. Interesting. I wonder why that's not there. Because in their examples, they call, well, load U underscore PS. If we go up and look, load U underscore PS. It's just for loading a float. So I wonder why this doesn't work. Say load UPS, double console I. I would have expected those to exist there, similar to this. Oh, unless it's, I mean, load UPS is there, right? It's just something that's there. Maybe it's because my destination is wrong. Okay. Oh, they have got a lot of things in here, but no 16-bit stuff. I wonder if that's on purpose. Yeah, so here they have VF32, VI32s. And here they have SIMD small int associated types. Interesting. Let's see if they have 16-bit stuff. Issues, 8-bit vectors, 16-bit vectors. Looking at their bug list. Could add 8-bit instructions eventually, but that might be a while. Okay, I didn't see the 16-bit ones. Go back a little bit. Because they have 16 width here, 16 associated type there. And where's their 16-bit load? All right, let's see if we can find something that returns a VI16. Well, that's only for add, subtract, and multiply. Well, how do you get one? Huh. All right, well, maybe I'll be checking out their code and trying to add 16-bit loads. I know they're going to look at me funny and say, like, why in the world would you want to do this? And really, it's because I don't have a huge amount of RAM, so I'm trying to limit the size of the type. But I'd like to operate on the smaller type size. All right. Sadly, I am being called away. I think this might end up being more of a normal thing where I stop around 9 o'clock my time on the hour here. But see, how would we add one of these things? Let's take a look real quick. Let's go to their source. Go over there. Back here. Unsafe, unsafe, unsafe. Yeah. Let's see, I can't log in there. All right, I just need to copy this into my other browser window. I think has me authenticated. All right, I'm gonna fork that. Oh, I've already forked it. Okay. Clone or download. Copy that. Let's go back to the code. Okay, so I haven't checked it out yet. Let's clone this. What am I going to do with SIMD? I'm going to try to do the battle calculation in less time. So if I can do it in less time, then that's more battles. And everybody likes more of those. All right, now we should probably make sure that this thing is up to date because I don't know when I forked this. Let's see, let me get this. Get add remote. What do we call this? Backmod. I always do that. It's remote add, not add remote. There we go. Fetch that. Make sure we're up to date. All right. Well, I think we're gonna probably call this. The next stream is probably going to be trying to add the 16-bit load intrinsics to SIMDs. Actually, it sounds kind of fun. Get to see a little bit of that. See, okay. Where do we even start in here? Probably. Wow, look at all these. AVX. Look at the different instruction sets. Load U, PD. You know what? This doesn't actually. Looks like they've got some macros and stuff in here. It might actually be pretty quick. All right, y'all. We're gonna raid someone. Anybody have a favorite? Actually, it's a little quiet out there today. And we're gonna go with Adam. I like this. I like to raid Adam. I get a lot of actually people walking through, finding me through Adam. He does host me on occasion. We're gonna raid him. Rust does have SIMD stuff built in, but the library that I want to use doesn't have all of the intrinsics that it has. Oh, yes. All right, thanks, y'all. We're gonna start the raid. Let's see. Today, Adam is actually doing Godot stuff. Designing the first Godot game, episode 3. Well, that sounds fun. All right, y'all. Until next time. Bye-bye.